So I thought I'd show you a little bit of my home automation dabbling and a little energy monitor I recently built and 3D printed as well. So this is the new energy monitor. I did have a bunch of current cost devices like this. They simply show you the amount of watts the house is using and connect via a current clamp on your incoming mains line. But they're not actually very accurate. They give you a good idea of what you're using, but because the voltage actually changes significantly, more than most people think, the actual wattage can't be calculated correctly or very accurately. They simply assume that you're on a 240 volt circuit, which is the halfway point between the 230 and 250, which everybody sort of settled on, when in fact, and I log the voltage quite carefully here, we can see, ignore the dropouts, that's when I turn the mains off, but we can see a typical day here. Voltage actually varies between 230 and 245, and the standards actually allow it to go a fair bit further than that as well. That actually makes a 200 or 300 watt difference even with the same amount of current, so you can't accurately work out wattage with these. However, I also wanted to monitor my solar generation, and to do that I would have had to have bought another little LCD thing. So I decided instead to build a better one, and what we have come up with is this, which looks a little bit like the current cost actually, although it's a nicer case. It's just a rough prototype, and what we have is current solar PV generation. This is a touchscreen, by the way. Our current consumption 491 watts. I'll zoom in on that so you can see it a little better. So our current generation from the photovoltaics, current consumption, and these are all real time. Diverting, I actually have set up so that excess power, so we've got about 500 watts of excess there at the moment, is diverted into various circuits like heaters and hot water. But I haven't linked the sensor back up yet, so it's just showing us dashes. The current generation for today, so 2.7 kilowatt hours today we've generated. Temperature of the hot water in the main domestic tank, just so we can keep an eye on what's going on. Current temperature in this room. This has a Dallas one-wire temperature sensor in it. It's pretty accurate. And here we have a little graph. The blue is actually generated power, and the white line along here is actually the current consumption. Down here there's an image. I'm not sure if it'll come out very clearly on the video, but it's triggered by the passive infrared sensor here. This is actually a home security camera as well, so it's recording all the time. But just for fun, I have a PIR in there to detect movement, which activates the screensaver, turns this on and off, but also takes images of movement, and I've currently got it displaying on the screen, and just the clock down the bottom. That's the camera module there, little HD camera, pretty much the same as you'd get in your cell phone. All this is, say, real time. Little Arduino, sorry, not Arduino, a little Raspberry Pi wireless inside here. So this actually is running a full, well, a version of Debian. So I can do a lot more with it. You can just SSH into this box, write scripts just like you can with any full-size Linux box. Quite interesting. All the data is sent back via a home automation protocol which I sort of invented for this house, and is logged in a central database. So if we want to look at generation, I can go to our sensor list, pull up our solar watts. This is our generation for today, or we can look at sort of entire periods. We go to today, you can zoom in, you see it quite spiky, but it's because there's various clouds and things. So you can see it climbs from around about 5 o'clock in the morning up to about 1200 watts it's generating, pretty much around now. It's dropped off to 800. We have a little happy house here when we're generating more than we're using. We can plot things, hot water temperatures, air temperatures. The spike here is because I moved the sensor to do this video. So we have hot water here. If we go to period, in fact, all this hot water here, all this heating you can see in between lows, has all been done with solar. Actually not used any paid for power to heat this water at all in the last sort of 16 days, I think, since I made this live. So it's quite a good way to use excess power that you'd otherwise be pumping back into the grid. We have PIR here. The way I've done it here, it actually monitors the amount of seconds since last movement, and that way the system can detect if a room is idle and do things like turn off lights, turn down heating and so on, and turn them back on again when the room is occupied. So there you go, all written in Python. Well, the code for the monitor is written in Python. Actually, the home automation system is written in PHP. But maybe some of you will find that interesting. Maybe not.